All right, I'm in Unit 4, Lesson 6, and this is Part 2 of the homework in Lesson 6, number 33. So it says, of all of the circular cone, all of the circular cones of slant height 8 centimeters. So, give myself a cone. Inside a cone, we need a couple key pieces of information, R and H, and of course they didn't give us either of these key pieces. They gave us slant height, which not overly helpful. Find the dimensions of the cone of largest volume. So optimization equation here is fairly apparent. 1/3 pi r squared h. We're optimizing volume. Got too many variables, so I need to replace them. And the relationship that develops here is right there. It's our right angle triangle. So I guess I'll put the equation. So hypotenuse squared equals a squared plus b squared. In this case, 8 squared equals r squared plus h squared. Now at this point, I'm deciding, do I want to get rid of the r or the h? When I look at the optimization equation, I see there's an r squared. In my constraint equation, I see there's an r squared. So I'm going to isolate for r squared because that's probably going to be my easiest substitution. So 8 squared is 64 minus h squared equals r squared. So there is my constraint equation, and that's what I'm going to throw into my volume equation. Volume equals 1/3 pi. R squared is going to be 64 minus h squared times h. I'm going to use distributive law here to clear it up. So, I mean, this is kind of up to you as to what you prefer. So I have to multiply my h in, and I'm going to multiply the 1/3 pi in at the same time. So I end up with 64 pi over 3, that's just a number, h minus pi over 3 h cubed. All right. So now I can take the change in rate of volume with respect to the height. Taking the derivative, I'm left with 64 pi over 3 minus, the 3's would cancel, so it would be pi h squared. We're optimizing, so we're going to let the change in volume with respect to height equals 0. So 0 equals 64 pi over 3 minus pi h squared. Each term has a pi, so that's going to save some time there. So that means that h squared equals 64 over 3, or h equals 8. Square root of 64 is 8 over root 3. I think it's just in units. And I'm going to rationalize the denominator. I'm quite happy with it in this form. Again, if you go to university, you're going to get into, if you're taking a math course, they'll want it rationalized. And it's going to just help me get to my correct radius right away. So I have 8 root 3 over 3 units. So there is my height for optimization. I'm going to use that then to determine my radius, so we can see what the match up with the answer. Equals r squared, so 64 minus 8 root 3 over 3 squared equals r squared. 64 minus, so I'm going to get 64 times 3 divided by 9 equals r squared. So the 3 will cancel down that 9, reducing it to a 3. Pretty sure 64 doesn't go into 3. So it'll be 64 minus 64 thirds, and in proper form. So that gives me 128 over 3 equals r squared. Square root of both sides. So I'm assuming that 128 must have a perfect square. 16 works. 128, what about 36? No, let's start with 16. So 128, square root of 128 is, 128 divided by 16 is 16 times 8. So that's going to be 4 root 8, excuse me, over root 3, which would be 8 root 2. over root 3. Again, rationalize the denominator. And I end up with 8 root 6 over 3 units. So therefore, for an optimal cone, H has to be 8 root 3 over 3 units, and R has to equal 8 root 6 over 3 units for that to work. And if you check the answer at the top, in the right area. So there we go. So that is the process to determine the optimal dimensions for a cone with a slant length of 8. If you have any questions or need clarification, let me know, and I'll try to give you a hand.